Now let's talk about the supervisor implementation. Um, as we see here above, the supervisor again has been enforced with a schema, output schema. So we are saying that we want the action to be noted here. So if it is routing, if it is planning and routing, and if it is asking the user again for the clarification. It also notes the target here, which is the data or the docs, the reason, the plan, question when it's supposed to be asked to the user, why is there a question when it's supposed to be asked to the user, and slots. This is like a scratchpad where where the agents can note down any sort of like communication when they are having when they are communicating internally. uh, After that, we have the prompt for the supervisor. You can see, yeah, I'm just telling it that there are two agents that you are responsible for. One is data agent, and it allows yeah. So yeah, we can skip this part here. We don't need that. Over the allowed tables, it's supposed to be running a SQL query and something like that. And we also say that the RAG agent is responsible for answering any questions regarding to the molecule pharmacology. After that, we see I have given it access to two particular tools: memory manage and search memory. This is in order to retrieve any code context from the state and store it and retrieve it the next time that we are using it. And yeah, we will see that how it can be particularly helpful to store and retrieve those information instead of always getting it from the user again or from the source again. I define the behavior for the agent next, which is to route between the questions and decide whether to call one agent or the other or both. You can decide to once you decide, you will route the conversation to that agent. Um, you can also decide to use both agents. I tell the supervisor. um, yeah, so just the very basic prompts here. We tell it to store any useful information, and then before sending the final answer, always ensure to properly format it. um, Below, I have given it some decision contract because it was having some trouble putting values for the action variable here. So I tell it to when to use route, when to use plan and route, and when to use final. um, yeah, it is just like to explore more about how and where to use structured outputs, because structured outputs are one way of us trying to understand how these agents are working, thinking, reasoning, and executing the functions that they have access to. And the same thing, I give it a output format. I tell the supervisor that return the JSON according to the schema we set above, which will be enforced by the caller. And we set some rules for it. um, so yeah, that is about the supervisor agent. Prompt for the supervisor agent. Let me show you what the implementation for the graph looks like. So this graph, this is the uh, final code file where everything comes together. The supervisor, the uh, the data agent, the RAG agent, uh, and Yeah, and our prompts, sorry, for our models for the supervisor, everything comes together here. The temperature variable here is to essentially give determinism to the models. So it is like a variable between 0 and 1. It's a float between 0 and 1. One representing the models to be extremely non-deterministic, and 0 representing the models to be very deterministic. um, as we go ahead, yeah, we just use the create supervisor here, and it's pretty straightforward from LangGraph in order to have this implementation, because yeah, there are like, if we can choose to like not use the create supervisor as well, and we can create like our own functions or our own definition for doing the supervisor. So we can individually add like respective nodes in there and have the nodes return all the output to the user directly, or to the supervisor, and supervisor return the output to the user. um, but yeah, for my implementation, which was like very straightforward, they you know it made sense to use the create supervisor or by itself, so I used that. But we can very well create a custom one as well. So once that is set, I give it the LLM access, the agents, the tools, the prompt. We say that handoff messages are true because we want to see, we want to be able to trace those messages. um, we give it an output format, supervisor decision schema that we talked about, and yeah, the output mode is set on full history so that we have like all the necessary details. Yeah, we can also give it the name like the IDE suggested, um, which will be very good. Okay, and here we compile it with the store. Oh yeah, so one thing which I wanted to talk about is the store. um, this store is the instance from the Supabase Postgres store that I talked about earlier. um, we can see it open over here again. So this is the Supabase Postgres store, and the model here is able to take up this store and store any of the relevant information here. I can quickly go through our store implementation, which is in the mem store file here. It's pretty simple. We just give it the API key and tell it to connect here, and it pretty much very efficiently connects here. To when we are opening a new Postgres store, we can just we can choose to set up the table structure ourselves, or use the, like, if we are using the LangGraph, we can use the setup function from LangGraph as well, which can just instantiate, like, which can just reference this store instance and set it up with all the necessary fields that are required in the table. So once we have that ready, the model will like efficiently go about using those. um, so yeah, that is all about the supervisor and also our graph. So this concludes our deep dive. Next up, we will see some examples on different prompts and how the model performs under different conditions.